Generally, acids react with metal to form salt and release hydrogen gas. For example, when dilute sulfuric acid reacts with zinc granules, zinc sulfate is formed and hydrogen gas is released. Pass the gas through soap solution. Hydrogen escapes into the air in the form of bubbles. Bring a burning matchstick near a hydrogen-filled bubble. Hydrogen burns with a pop sound and matchstick is extinguished. Metal displaces hydrogen from the acid. Similarly, strong base like sodium hydroxide reacts with zinc granules to form sodium zincate along with the evolution of hydrogen gas. This reaction is not possible with all the metals. Carbonates react with acids. When metal carbonate like sodium carbonate, that is Na2CO3, reacts with an acid like hydrochloric acid, salt is formed along with carbon dioxide and water. The gas evolved can be identified by passing it through lime water, that is CaOH2. The gas turns the lime water milky, and therefore we can conclude the gas to be carbon dioxide. On passing excess of carbon dioxide, water-soluble calcium bicarbonate is formed, which dissolves in water, so the milkiness disappears. Similarly, when metal hydrogen carbonate like NaHCO3 reacts with dilute hydrochloric acid, salt and water is formed with the evolution of carbon dioxide. Here in this module, we will study about reactions of acids and bases with each other. Take about 2 ml of dilute NaOH solution in a test tube and add 2 drops of phenolphthalein solution. You will observe that the color of the solution becomes pink. Now, add dilute HCl solution to this solution drop by drop. Color of the solution now changes to colorless from pink. Now again, add NaOH to the mixture drop by drop. The pink color reappears. The effect of base NaOH is nullified by the acid HCl, but with further addition of base NaOH, the pink color reappears. In fact, the reaction between an acid and a base gives a salt and water, and this reaction is called as a neutralization reaction. Metallic oxide with base. In this module, we will learn about the reaction of metallic oxide with an acid and of non-metallic oxide with base. Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. The color of the solution becomes blue-green and copper oxide dissolves. The blue-green color of the solution is due to the formation of copper chloride. In fact, reaction of metallic oxides with acids results in formation of salt and water. Now let's see the reaction of non-metallic oxide with base. Take a fixed amount of lime water, that is CaOH2, in a test tube, which is a base, and pass CO2 through it. When CO2 is passed through lime water, calcium carbonate, that is CaCO3, is formed. Lime water turns milky because of the formation of calcium carbonate. Generally, non-metallic oxides react with base to form salt and water. Part 1. Hey friends, want me to show you a magic? Come on then, observe me carefully. Watch me put these solutions one by one on this magical paper. Did you see how I got different colors every time I put these solutions on this paper? You must be surprised, aren't you? Are you sure this is a magic? Oh, come on. This is no magic. This is simply science. In fact, the liquids that I used are different, and this special paper strip is called a pH paper. Now you all must be eager to know what a pH paper is and how does it show different colors with different solutions. Let us discuss this in detail. We know that an acidic solution contains hydrogen ions, that is H+ ions, and a basic solution contains hydroxyl ions, that is OH- ions. Another important fact to remember is that a solution with more H+ ions is more acidic. That is, a strong acid. While the one with more OH- ions is more basic. That is, a strong base. To determine how strong a given acid or a base is, we make use of a universal indicator, which is a mixture of several indicators. This universal indicator gives different colors at different concentrations of hydrogen ions in a solution. Strength acid and base solution pH value, Part 2. We use a specific scale for measuring the hydrogen ion concentration known as the pH scale. The pH of a solution is a number which indicates the acidic or basic nature of a solution. It ranges from 0 to 14. The pH of a neutral solution is 7. Values less than 7 represent acidic solutions, while those greater than 7 represent the basic nature of solutions. If the acidic nature increases, that is, the hydrogen or hydronium ion concentration increases, the pH goes down. On the other hand, if the basic nature increases, the pH of the solution goes up. Generally, paper impregnated with the universal indicator is used for measuring pH. Such paper is known as the pH paper. Let's take different solutions and observe each on different strips of pH paper. Now observe the different colors that these solutions give with the pH paper on this table. Can Can you conclude something from this difference in color? Yes, we can identify whether the given solution is acidic or basic. H value, part 3. The strength of acids and bases depends on the number of H plus ions and OH minus ions produced, respectively. Let us understand this with the help of an example. If we take hydrogen chloride and acetic acid of the same concentration, say 1 molar, then these produce different amounts of H plus ions. Acids that give rise to more H plus ions are said to be strong acids, while the ones that give less H plus ions are said to be weak acids. Similarly, if we take two bases of the same concentration, say 1 molar NaOH and 1 molar NH4OH, then the base that gives more OH minus ions is a strong base, and the one that produces less OH minus ions is considered a weak base. Now I'm sure you have identified the reason why the different solutions were giving different colors with the pH paper. It is because of the different strengths of the solutions that differentiates them into strong and weak acids and bases. pH is the measure of H plus ions present in a solution, indicating the acidic or basic strength of the solution. The pH of a neutral solution is 7. Values less than 7 on the pH scale represent an acidic solution. Whereas, with the increase in the values from 7 to 14 on the pH scale, the basic strength of the solution increases. Our body works within the pH range of 7 to 7.8. pH of acid rain is 5.6. When the water from the acid rain flows into rivers, it lowers the pH of the river water, which causes lots of damage to the aquatic life. Plants also require a specific pH range for healthy growth. You know that our stomach produces hydrochloric acid, which means its pH is less than 7. Excess production of acid by the stomach causes pain and irritation. We usually take antacids to get rid of this pain. For example, magnesium hydroxide, that is MgOH2, is an antacid which neutralizes the excess acid. Also, after eating, the bacteria present in the mouth starts producing acid due to the degradation of sugar and food particles left over in the mouth. This reduces the pH of the mouth below 5.5, and the tooth enamel, which is made up of calcium phosphate, that is CH3PO4(2), which is the hardest substance in the body, starts decaying. Therefore, it is advised to clean the mouth after eating food using some toothpaste. These toothpastes are generally basic in nature. When a bee stings someone, it leaves some acid which results in pain and irritation. Using mild base like baking soda can give some relief when applied over the affected area. Similarly, nettle leaves produce stinging sensation when contacted because they inject formic acid, that is HCOOH, which results in burning pain. Rubbing some leaves of dog plant over the affected area provides relief to the irritation.
Do acids produce ions only in aqueous solution? To find the answer, let us do some experiments. Take about 1 gram solid NaCl in a clean and dry test tube and set up the apparatus as shown. Add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? Test the gas evolved successively with dry, blue litmus paper. And wet blue litmus paper. In which case does the litmus paper change color? On the basis of the above activity, what do you infer? This experiment suggests that hydrogen ions in HCl are produced in the presence of water. The separation of H plus ion from HCl molecules does not occur in the absence of water. The reaction being HCl reacts with water to give hydronium ions, that is, H3O plus and chlorine ions. It is very important to understand that hydrogen ions cannot exist alone, but they exist after combining with water molecules. Thus, hydrogen ions must always be shown as H plus ions or hydronium ion, H3O plus ions. It can be represented by the reaction as hydrogen ions react with water to form hydronium ion, H3O plus. Now here we have seen that acids give H3O plus or H plus aqueous ion in water. Let us see what happens when a base is dissolved in water. The reaction will be NaOH S is dissolved in water. It gives Na plus ions and aqueous plus OH minus aqueous ions. Similarly, if KOH S is dissolved in water, it gives K plus ions plus aqueous plus OH minus aqueous ions. Also, if MgOH2 S is dissolved in water, it gives Mg plus 2 ions and aqueous plus 2 OH minus aqueous ions. So we can conclude that bases generate hydroxide or OH minus ions in water. Bases which are soluble in water are called alkalis. But do you know? All bases do not dissolve in water. An alkali is a base that dissolves in water. They are soapy to touch, bitter, and corrosive. Students, it is very important to understand that we should not taste or touch them as they may cause harm to us. So, to conclude, all acids generate H plus aqueous. And all bases generate OH minus aqueous. We can view the neutralization reaction as follows. Acid plus base gives salt plus water, or H plus X minus plus M plus OH minus gives MX plus H2O, where H ions from the acids react with OH minus ions from the base to form water. Let us see what is involved when water is mixed with an acid or a base. Take 10 ml water in a beaker. Add a few drops of concentrated H2SO4 to it. And swirl the beaker slowly. Touch the base of the beaker. Is there a change in temperature? Is this an exothermic or endothermic process? Repeat the above activity with sodium hydroxide pellets and record your observations as shown here. From the experiment, we understand that the process of dissolving an acid or a base in water is a highly exothermic one. Care must be taken while mixing concentrated nitric acid or sulfuric acid with water. The acid must always be added slowly to water with constant stirring. If water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burns. The glass container may also break due to excessive local heating. You will generally find warning signs on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide pellets. It is important to understand that mixing an acid or a base with water results in a decrease in the concentration of ions, H3O plus, OH minus per unit volume. Such a process is called dilution, and the acid or the base is said to be diluted. Salts of a strong acid and a strong base are neutral with pH value of 7. On the other hand, salts of a strong acid and weak base are acidic with pH value less than 7. And salts of a strong base and weak acid are basic in nature with pH value more than 7. Chemicals from common salt. By now you have learned that the salt formed by the combination of hydrochloric acid and sodium hydroxide solution is called sodium chloride. This is the salt that you use in food. Seawater contains many salts dissolved in it. Sodium chloride is separated from these salts. Deposits of solid salt are also found in several parts of the world. These large crystals are often brown due to impurities. This is called rock salt. Beds of rock salt were formed when seas of bygone ages dried up. Rock salt is mined like coal. You must have heard about Mahatma Gandhi's Dandi March. Did you know that sodium chloride was such an important symbol in our struggle for freedom? Common salt, a raw material for chemicals. The common salt thus obtained is an important raw material for various materials of daily use. Sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. Let us see how one substance is used for making all these different substances. The first is sodium hydroxide. When electricity is passed through an aqueous solution of sodium chloride called brine, it decomposes to form sodium hydroxide. 2 NaCl plus 2 H2O gives Cl2 plus H2 plus 2 NaOH. The process is called the chlor-alkali process because of the products formed where chlor stands for chlorine and alkali stands for sodium hydroxide. The reaction being, sodium chloride reacts with water to form NaOH aqueous plus chlorine plus hydrogen gas. chlorine gas is given off at the anode, the reaction being 2Cl minus gives Cl2 plus 2E minus. And hydrogen gas at the cathode, the reaction being 2H2O plus 2E minus gives H2 plus 2OH minus. Sodium hydroxide solution is formed near the cathode. It is important to note that the three products produced in this process are all useful in our daily lives. Let us see another important substance prepared with common salt as raw material. Bleaching powder. You already know that chlorine is produced during the electrolysis of aqueous sodium chloride or brine. This chlorine gas is used for the manufacture of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slaked lime, that is CaOH2. Bleaching powder is represented as CaOCl2, though the actual composition is quite complex. The reaction being CaOH2 plus Cl2 gives CaOCl2 plus H2O. Let us now understand some uses of bleaching powder. Bleaching powder is used for bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper factories, and for bleaching washed clothes in laundry. It is used as an oxidizing agent in many chemical industries and for disinfecting drinking water to make it free of germs. Let us see another important substance prepared with common salt as a raw material. Baking soda. The soda commonly used in our kitchen for making tasty crispy pakoras is the baking soda. Sometimes it is added for faster cooking. The chemical name of the compound is sodium hydrogen carbonate or NaHCO3. It is produced using sodium chloride as one of the raw materials. The reaction being NaCl plus H2O plus CO2 plus NH3 gives NH4Cl plus NaHCO3, which is sodium hydrogen carbonate. It is important to understand that sodium hydrogen carbonate is a mild, non-corrosive base. The following reaction takes place when it is heated during cooking. 2NaHCO3 on heating gives Na2CO3 sodium carbonate plus H2O plus CO2. Sodium hydrogen carbonate has got various uses in the household. Let us now study some uses of sodium hydrogen carbonate. It is used for making baking powder, which is a mixture of baking soda, sodium hydrogen carbonate, and a mild edible acid such as the tartaric acid. When baking soda is heated or mixed in water, the following reaction takes place. NaHCO3 plus H plus from any acid gives CO2 plus H2O plus sodium salt of acid. Carbon dioxide produced during the reaction causes the bread or cake to rise, making them soft and spongy. Sodium hydrogen carbonate is also an ingredient in antacids. Being alkaline, it neutralizes excess acid in the stomach and provides relief. It is also used in soda acid fire extinguishers. Let us see another important substance prepared with common salt as a raw material. Washing soda. Another chemical that can be obtained from sodium chloride is Na2CO3.10H2O or washing soda. You have seen above that sodium carbonate can be obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. It is also a basic salt, the reaction being Na2CO3 plus 10H2O gives Na2CO3.10H2O. In this equation, can you tell what does 10H2O signify? Does it make Na2CO3 wet? We will address this question in future modules. Students, sodium carbonate and sodium hydrogen carbonate are useful chemicals for many industrial processes as well. Let us understand the uses of washing soda. Sodium carbonate or washing soda is used in glass, soap, and paper industries. It is used in the manufacture of sodium compounds such as borax. Sodium carbonate can be used as a cleaning agent for domestic purposes. It is used for removing permanent hardness of water. A solution is a homogeneous mixture of two or more substances. You come across various types of solutions in your daily life. Lemonade, soda water, etc. are all examples of solutions. Usually we think of a solution as a liquid that contains either a solid, liquid, or a gas dissolved in it. But we can also have solid solutions or alloys. And gaseous solutions or air. In a solution, there is homogeneity at the particle level. For example, lemonade tastes the same throughout. This shows that particles of sugar or salt are evenly distributed in the solution. A solution has a solvent and a solute as its components. The component of the solution that dissolves the other component in it, usually the component present in larger amount, is called the solvent. The component of the solution that is dissolved in the solvent, usually present in lesser quantity, is called the solute. Some examples of solutions are aerated drinks like soda water, etc. are gas in liquid solutions. These contain carbon dioxide, gas, as solute, and water, liquid, as solvent. A solution of sugar in water is a liquid solution. In this solution, sugar is the solute and water is the solvent. Let us now learn about properties of solution. Properties of a solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nm, 10 raised to the power minus 9 meter in diameter, so they cannot be seen by naked eyes. Because of a very small particle size, they do not scatter a beam of light passing through them, so the path of light is not visible in a solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed. That is, a solution is stable. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain. What is suspension? A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. What is suspension? A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. Properties of suspension. A suspension is a heterogeneous mixture. The particles of a suspension can be seen by the naked eye. The particles of a suspension scatter a beam of light passing through it and make its path visible. The solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. What is a colloidal solution? In a colloidal solution, the particles of a colloid are uniformly spread throughout the solution. Due to the relatively smaller size of particles as compared to that of a suspension, the mixture appears to be homogeneous. But actually, a colloidal solution is a heterogeneous mixture. For example, milk. Because of the small size of colloidal particles, we cannot see them with naked eyes. But these particles can easily scatter a beam of visible light as shown here. This scattering of a beam of light is called the Tyndall effect, after the name of the scientist who discovered this effect. Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. Tyndall effect can be observed when sunlight passes through a canopy of a dense forest. In the forest, mist contains tiny droplets of water which act as particles of colloid dispersed in air. Properties of a colloid. A colloid is a heterogeneous mixture. The size of particles of a colloid is too small to be individually seen by naked eyes. Colloids are big enough to scatter a beam of light passing through them and make its path visible. They do not settle down when left undisturbed. That is, a colloid is quite stable. They cannot be separated from the mixture by the process of filtration. But a special technique of separation, known as centrifugation, can be used to separate the colloidal particles. The components of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component or the dispersed particles in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersion medium. Colloids are classified according to the state: solid, liquid, or gas of the dispersing medium and the dispersed phase. A few common examples are given here in the table. From this table, you can see that they are very common in our everyday life.